So an important part of function notation and the way in which we write functions is what we call the domain and the range. Okay, so they're both very similar, but you have to understand the difference between the two of them. Okay, so if a function is written in the form y equals f of x, which it generally is, okay, it will just be y equals x squared, y equals cos x, whatever the hell it is. Okay, it's y is a function in terms of x. Okay, and that's what we mean when we say that. But what we're talking about when we're talking about the domain is the possible values of x. Okay, so what's going to happen is basically we're going to put x values in, and there'll be certain ones that basically just don't work. Okay, so depending on what the function is, there'll be certain values that if we put x in, the function just won't work. It just won't compute. And you'll have seen that before, and you'll have seen the domain written in certain questions. When you're in National 5, if you think back to the algebraic fraction questions, there was always a domain written along the side of it. Okay, you're never really concerned about it then. We did discuss it briefly at the time, but now what we're going to do is we're going to find out for ourselves what that domain should be. Okay, right. Similarly, if you had a range, it's the possible values of y. Okay, so within that function, okay, basically the answers that are possible is what we're talking about when we're talking about the range. Okay, it's very useful to be able to look at the graph for both of these things, though. And if you can look at the graph and you can kind of look at your x values and your y values, and you can find both the domain and range. So it's going to be useful to be able to understand what the graphs of these different functions look like. Right, in terms of remembering which one is which, because the exam questions are going to be what is the domain, what is the range, find the domain, find the range. It's not going to be anything more than that, so you need to know the difference, which one's x, which one's y, and it's just simple to follow. It's just alphabetically, basically. Okay, domain comes before range, x comes before y. So domain is dealing with the x values, range is dealing with the y values. Okay, so we'll start by looking at the range. Okay, and we're just going to go straight into some questions here. And I've got 3 graphs, and we're going to state the range of these functions illustrated by these graphs. Okay, so we've got the equations at the bottom there. So this first one, you've got f of x equals x squared minus 4x plus 3, and the second one we've got sine x, and this third one we've got 2 to the power of x. It's an exponential function. We've not dealt too much with them just yet, but we're still going to try and understand what the range means. So in terms of the graph, what we're basically looking at is the y values. Okay, so we're almost looking kind of horizontally along. So you can see here that there's 2 values of 7, there's 2 values for 6, there's 2 values for 5, so on and so forth. But the point is when you get further down, okay, so there's 2 values for 0, there's 2 values for 1, there's 1 value for minus 1, but then anything below that, there are no values on that function. Okay, so in other words, the range of values for that is anything that's minus 1 or above. Okay, because you can see generally when we're writing these functions, when we're drawing these functions as graphs, obviously these go on, these are infinite, these just go on forever and ever and ever, but they keep going in that direction, in which case they pass all possible y values that are above 7. But the idea is it will never come back down again. So the lowest point it gets to is minus 1. Okay, so that's a value within that range. Okay, is minus 1, but anything below that isn't. Okay, so the y-coordinates represent the range of the function as these are all functions of x. Okay, so the range here in this first one is the set of all real numbers which are greater than or equal to minus 1. And this is important too. It's the set of all real numbers. Okay, basically just all the possible numbers, both positive and negative, and decimals as well. Okay, the writing of it is slightly more difficult though. It's easy enough to write as a sentence. It's easy enough to say, but what we basically say, taking that sentence into figures and this kind of notation, we'd have to write it as y is in the set of real numbers. That's what that basically means. So the y values we can take are all real numbers, basically where y is greater than or equal to minus 1. So we can see from the graph, okay, that it could have been minus 1. Okay, that's a potential value. And if you put it into the function, or if you put 2 into the function, you can see that you would have got an answer of minus 1. And then anything above minus 1 is also a possible value. Okay, so y is greater than or equal to minus 1. Anything less than that is not within the range. So that's all we write. Y is greater than or equal to minus 1. So similar kind of idea for the second one. Okay, you can see basically here we've got 3 values for 0. And remember, this is a sine graph. It goes on forever and ever and ever, but it waves. It goes up and down, up and down, up and down. And it never actually gets above 1. It never actually gets below minus 1. Okay, well, for a standard sine x graph anyway. Obviously, if we had 2 sine x, then the amplitude is increased. But if it's just a standard f of x equals sine x graph, it gets to 1, and it does get to 1. Okay, there is a value of 1. We know there's a value of 1 when x is 90, and we know there's a value of minus 1 when x is 270. But it never gets to a value above that. Okay, so similar kind of idea. The range here is the set of all real numbers between and including minus 1 and 1. So in terms of how we write that, the first bit's still the same, okay? Y is in the set of real numbers, okay? But Y is anything between -1 and 1. So Y is greater than or equal to -1, okay? But also less than or equal to 1. And that's how we write it. That's how the simplest way of writing it, at least. Okay, so Y is in the set of all real numbers, so all possible numbers between basically -1 and 1. Okay, but nothing less than -1, and nothing greater than 1. So in this last one, again, it's the same kind of idea, and you'll get a little bit more knowledge about exponential graphs soon. But what's basically happening here is it gets less and less and less and less and less and less, but it never actually gets to 0. Okay, see, it's basically approaching this x-axis, but it never actually reaches it. Okay, and as I say, you'll learn more about that later on. In this direction, okay, it'll keep going and going, and again, similar to the x squared graph, it'll just keep getting bigger and bigger and bigger, in which case it'll cover all those y values, but never gets to 0 and never gets below 0. Okay, so the range here is a set of all real numbers which are greater than 0. As I say, you'll get more idea of the fact that it never actually reaches 0 here. Okay, and if you think about the function itself, okay, the idea is if you've got a power, you can never actually do something 2 to the power of something will never actually equal 0. We know 2 to the power of 0 is 1. Okay, we know 2 to the power of 1 is 2. We know 2 to the power of -1 is a half. It never actually gets to the point where the y value equals 0. Okay, so again, similar kind of writing. Y is all in the set of all real numbers, but y has to be greater than 0. Okay, right. So that's the range of a function. Okay, domain of a function is, as I say, is dealing with the x values, and you'll be familiar with it because you see this this error in your calculator. And what this basically this maths error is telling you when you get your calculator, when you get it in your calculator, is that there's something wrong with the input. You basically put in an x value that is not possible. So if you think about the different situations when you get this error, okay, it's different things like, for example, if you wanted to divide by 0, okay, and if you can try that in your calculators, you'll see any number divided by 0 is not possible. You can't divide by 0. Okay, so that would give you a maths error in your calculator. Also, if you wanted to find the square root of a negative number, we can't do that. Okay, so you'd get a maths error in your calculator. And these two are the main things that we want to focus on when we're thinking about the domain of a function. So what we're basically saying is we don't want x to equal those values in those situations. So if we have to divide by an x, we don't want that x value to equal 0. If we have to find the square root of an x, we don't want that x value to be a negative number. We go along these kind of lines in terms of writing the domain of a function. Okay, so we've got this f of x value or graph here, which is sine x. Okay, just pop that to one side just now. Okay, in the second question, restriction might also have been put on the domain. Okay, so there might have also been a restriction in terms of the x value. So there's a restriction in terms of the range here. The range doesn't go above 1, doesn't go below -1, which we discussed in that last slide. Okay, but we might have also put a domain on here, right? Both in terms of the values of x that it could have, okay, it could have to basically work, and it's also in terms of what we want it to have. So we might want this to be an interval. We might only, and generally we do when we're dealing with trig graphs, we only want to see a certain part of it. So we want to limit basically x to the real numbers from 0 to 360. So that would be a restriction of choice, not of necessity, as the graph of y equals sine x is infinite. Okay, however, it is not always a case of choice. So if you had a function like these two, as I was just discussing, basically if we want to divide by an x, or if we want to find the square root of an x. So in this first one, x cannot equal 1. If x was to equal 1 there, then we'd be dividing by 0. The idea being that we'd have 1 divided by 1 minus 1. 1 minus 1 is 0, so then we'd be left with 1 divided by 0. And the same idea, if you put that in your calculator, you can't do it. You cannot divide by 0. So the domain of this one, okay, this first function here would be x cannot equal 1. And as I say, if you remember back to algebraic fractions in National 5, you'd always see this. If the function was 1 over 1 minus x, alongside it, you'd have this x cannot equal 1. So we're basically, and now we're in higher, we're establishing what the domain would be. So we're basically putting this in alongside our functions. And it's determined by the values that x could not equal if that function is going to work. Okay, so for the second one, if we've got the square root of x, the idea is we can find the square root of any number apart from negative numbers. So x cannot equal anything less than 0. So basically, we want x to be anything that's greater than or equal to 0. We can find the square root of 0. Square root of 0 is just 0, so that's fine. It can equal 0, but it has to be greater than 0 as well. Okay, we can't have it less than 0. In other words, you cannot find the square root of a negative number. Okay, so using those two main facts, okay, you have a lot of different questions involved around domain. Okay, and what we're trying to do here is we're determining any restriction on the domain of each of these functions and hence state the largest suitable domain. So what we want to do going into these questions is we're trying to think, what values can x be? What values do we want x to be? In other words, what values do we not want x to be? Okay, so here in this first one, what we basically have is we have a division. Okay, so we don't want to be in a situation where we're dividing 1 by 0. And for that to happen, then the idea is that x plus 3 cannot equal 0. Okay, as long as that bottom bit, as long as the denominator doesn't equal 0, then we're sweet. We're absolutely fine. Okay, so we start almost with an equation: x plus 3 cannot equal, so an equal sign with a line through it, cannot equal 0. And then we basically just solve this equation. If x plus 3 cannot equal 0, then x cannot equal minus 3. Same way as we solved equations before, take away 3 from both sides, x cannot equal minus 3. Okay. Again, you can just look at that. You can think, right, if x was equal to minus 3, then the bottom would equal 0, and we don't want the bottom to equal 0 because we can't divide by 0. So that's our domain. Okay, x cannot equal minus 3. Right, in the second one, okay, this time we've got a square root. And the idea is that we can't find the square root of a negative number. So we want x plus 5 to be greater than or equal to 0. Okay, and again, we've got an equation here. It's an inequation this time, but still something that we can solve. X plus 5 has to be greater than or equal 0, but we want to solve it specifically for x. So take 5 away from both sides. X has to be greater than or equal to minus 5. And that's the domain. That's what will allow this function to work. Anything, okay, where x is not greater than or equal to minus 5. In other words, if x was less than minus 5, okay, this wouldn't work. And again, you can check that for yourselves. If x was minus 6, this would be minus 6 plus 5, which is minus 1. We can't find the square root of minus 1. Okay, until to advanced higher, you can't find the square root of minus 1 anyway. So that's our domain. X has to be greater than or equal to minus 5. Right, and the third one there, it's a little bit more complicated now, but it's very similar to the first one, because basically what we want is we want the bottom to not equal 0. So we don't want x squared minus 3x plus 2 to be equal to 0. Again, this is an equation, but it's obviously a quadratic equation, and we have to solve this accordingly. Okay, so what we want to do when we're solving a quadratic equation is to factorize it. So x minus 1 and x minus 2 cannot equal 0. Okay. In other words, each individual bracket cannot equal 0. X minus 1 cannot equal 0, in which case x cannot equal 1, and x minus 2 cannot equal 0, in which case x cannot equal 2. If that was to be the case, if either of these brackets were to equal 0, then the whole bottom would equal 0, and we don't want that to be the case. Okay, so x cannot equal 1 or 2. Okay. Right, for this fourth one, okay, this is a little bit more awkward, and this is something that relates to something later on in the course, okay, which we'll see in a bit more detail, but it's not quite as straightforward as you might think. It's very similar to the second one, obviously, in terms of the setup initially, but the final part is a little bit different, okay? But the idea is, again, we don't want to find the square root of a negative number, so we want x plus 1 times by x minus 2 to be greater than or equal to 0. What we've basically got is we've actually got something very, very similar to what we had here, but we have to think in a bit more detail about this whole idea, this idea that it has to be greater than or equal to 0. It's not quite as simple, and this is what most people think. It's not quite as simple as doing x plus 1 is greater than or equal to 0 and x minus 2 is greater than or equal to 0, because that won't make sense at the end of it all. What we actually have to do is we have to think about what the graph looks like, okay? And what we want to on the graph is where on the graph it is greater than or equal to 0. What we've got to think about here is this is not the graph of the overall function, it's just the graph of what we're trying to find the square root of. Okay, so the graph of this, basically what this form tells us, and if we don't have this form for something like this, basically what we want to do is put it in a factorized form so we can find where it crosses the x-axis. Okay, so we know it's going to cross the x-axis when x plus 1 and x minus 2, or x plus 1 times by x minus 2, sorry, equals 0, in which case it's going to cross the x-axis at minus 1, and it's going to cross the x-axis at 2. Because it's positive, in other words, it's not negative, we know it's a smiley face. Okay, so it goes through minus 1, it goes through 2. Don't care about where this point is. All I care about is these two values, because what I'm actually looking for here is where the graph is greater than or equal to 0. And that's at this point here, and it's at this point here. Okay, and they're the values that I'm looking at for my domain. Okay, so in other words, all these values here are basically when x is less than or equal to minus 1. Remember, again, this is infinite. This goes on forever and ever. And it's not a very good shape because it probably would actually go up in this direction more. But the idea is that anything that's less than or equal to minus 1, okay, is following this domain that I was looking for in the first instance. This is where the values are greater than or equal to 0. So at this point and all of these points, which I can describe as by saying x is less than or equal to minus 1. I can say the same on the other side as well. Okay, so at this point, okay, the domain is fine, and all of these points as well. So in other words, or x is greater than or equal to 2. Okay. Right, similarly, if this was reversed, if you were basically looking for x plus 1, x minus 2 to be less than or equal to 0, it would be all these values in between. In other words, where x is greater than minus 1, but less than 2. Okay, so it's very, very important to understand the difference between this one and this one. Okay, it's not just a case of saying x plus 1 is greater than or equal to 0 and x minus 2 is greater than or equal to 0. Because if you think about it, if you go one step further from that, that won't really make any sense. What you'd have there is you'd have x is greater than or equal to minus 1 and x is greater than or equal to 2. You can't have both of those things in the same equation. So you have to think in terms of the graph. Okay. Right, for this last one is basically a combination of the two things, because what we're doing here is we're actually dividing by this bottom function as well, but because we're finding the square root of it, we don't want the square root to equal a negative number, okay? But we also don't want the whole bottom to equal 0. So this is, as I say, a combination between these two. You just got to be very, very careful about your symbol here. We want 1 minus x to be greater than 0, but we don't want it to equal 0. For the square root bit, it could equal 0. Okay, that would be fine, but if it did equal 0, then the square root would equal 0, and then we'd be dividing by 0, which we can't have. So we basically just want the 1 minus x here to be greater than 0. Okay, it gets us past the square root if it's greater than 0, because we can find the square root of a positive number, and then we'd be left with a positive or negative number, which we can divide into 1. Okay, so it's just a case of really getting the right symbol here. 1 minus x is greater than 0, in which case x has to be less than 1. Okay, so just remember the difference between ranges and domains. Range is dealing with your y values, domain is dealing with your x values. And that's the main thing to kind of glean from here.